This video is a discussion on how to make a reliability test of your questionnaire based on your questionnaire to get the data of your variable. So we are to use the Cronbach Alpha as one of the method in determining the reliability test of the questionnaire. It has to be noted that the Cronbach Alpha is applicable for a questionnaire that is Likert scale. When we say Likert scale, it's answerable by 5, 4, 3, 2, 1 or 4, 3, 2, 1 depending on the scale. Example, 5 is very much aware, 4 is much aware, 3 is aware, and so on and so forth. So again, to test the reliability of your questionnaire, you should test it using Cronbach Alpha. Why do you need to test the reliability? As a researcher, you must have a very reliable data from a reliable questionnaire because you cannot simply gather the data whatever you want or whenever you want without making sure that the tool you use in gathering data is reliable, because it's useless to analyze your data when its gathering method itself has a problem because the tool being used is not reliable. So this is the formula of the Cronbach Alpha. You can read this in the book of Cronbach in 1951, page 299. So alpha there is the symbol for the reliability level is equal to n over n minus 1. The n here, you have to take note that it's not the sample size, but it's the number of questions in the questionnaire. So we can represent k instead of n, or because it would give you a confusion when it comes to sample size. So again, the n here is the number of questions. So example, if you have 10 items in your questionnaire, then your n is 10, not the number of respondents, because the number of respondents can also be computed using Cochrane formula. Now, we will discuss that in another video. So, the quotient of n and n minus 1 shall be multiplied to the difference of 1 and the quotient of summation of v sub I, where I starts from whatever number it will start, over v sub t. This summation of v sub I is actually the sum of all variances of your questionnaire. So example, if you have 10 questions in your questionnaire, you must get one variance per question. So you must have 10 variances. And you add all the variances, you call that a summation of variance, or summation of v sub I, where I start from 1 or and so on and so forth. Well, this v sub t is the variance of the total. How do you get that? You have to add all the responses for each respondent in all items. Example, you have 1 to 10 items. So if these respondents check all 5 to these 10 items, so the total is 50. And then all the sum shall be subjected for variance in all respondents. So if you have 100 respondents, the total shall be computed for variance. So we call that as variance of the total. So the results shall be divided here, and the quotient shall be subtracted from 1, and the difference shall be multiplied to the quotient of the previous n over n minus 1. And that is the result of the Cronbach Alpha. Now, how do we interpret whether the level is reliable or not? This is now the scale. So the alpha, if the alpha is greater than or equal to 0.9, so meaning it will start from example 0.901 example. So if it's greater than or equal to 0.9, then you can say that your questionnaire is excellent, meaning you are already confident to distribute the questionnaire for data gathering. But if the alpha level after the computation, if the alpha level is just greater than 0.8 or equal to 0.8 but less than 0.9, example from 0.801 to 0.8999, so your level is only good. It's good level. However, you can proceed to data gathering. You can distribute the questionnaire using that tool because its reliability is good. But if your reliability after the computation of Cronbach Alpha is greater than or equal to 0.7 but less than 0.8, then the level is just acceptable. Well, there's no problem with the questionnaire. It's still acceptable by the people. So you can proceed to data gathering. However, if the data is greater than or equal to zero point 0.6 but less than 0.7, your questionnaire is questionable, meaning you must have to analyze each item. You call that item analysis, whether each item contributes to the whole variable itself, because sometimes you are putting items to the questionnaire wherein those items already do not contribute to the variable. Example, you're talking about satisfaction, and you're talking about satisfaction in all other items, wherein there are items there where it does not talk about satisfaction, but it talks already stress level. So you have to analyze only when the alpha level is greater than or equal to zero point 0.6 but less than 0.7. But if your alpha is greater than or equal to 0.5 but less than 0.6, of course, you will not do the item analysis. You have to review everything because your questionnaire is poor. You cannot distribute that because in the first hand it's poor. The more if your alpha level is less than 0.5. If it's less than 0.5, so from positive 0.5 down to negatives, it's unacceptable. So never think of item analysis, revamp totally. So you make another one from the start. That is the result when the alpha is unacceptable. So how do we do that? If you notice in the formula, what is important is getting the variance. And how do we get the variance? You have the formula. This is the shortcut. The summation of x squared minus summation of x squared all over n minus 1. Your x here is the data itself. And your square is the square of the data. So example, if the response is 5, so you square the 5, it becomes 25. You add all the squares, divide it by n. Your n now is the number of respondents. Unlike in the previous, I told you that your n here is the number of items. But in this variance, your n is the number of respondents, not the number of items. So if you do this, then you are getting the variance. I will show to you an example on how to compute. Example here. I have 5 respondents. But mind you, if you do the pilot testing, you must have at least, meaning the minimum is 30. But ideally, it's 100 and above number of respondents. But in my case, for the sake of example, I will just give you 5 respondents. Example, there are 5 questions also. Question number 1, question number 2, question number 3, 4, and 5. So these are the response. Example, it's 10-point scale wherein the respondents are going to check it's 10 if excellent, then 0 if not excellent. So 10-point scale instead of 5 or 4. So remember, it's 10. And these are the respondents' response. Example, respondent number 1. In question number 1, the rating is 10. Then question number 2, it's 8, 9 in question 3, and 10 in question number 4. Well, question number 5 is 8. Now, since the data here, the example has 5 questions, so meaning our n for the alpha is 5. And then we have to get the variance for us to facilitate in the formula. So our n here now is 5, and we need the summation of variance over variance. So these are the scores, the 10 until 9. These are the scores. And if you do that manually for getting the variance of this question number 1, the 2.5 is actually the variance. And how do we get the variance manually? We are going to consider that each response is x. So example, 10 is x, another x is 8. It's from the responses. And you have to get the square of x. So what will happen if 10 is squared? So 10 times 10 is 100. So you finish squaring all the data here, you will have the x squared. So what will happen after? If you look at in the formula of the variance here, you need the summation of x squared and the summation of x. So what you will do is you will add all the x. Here the total is 40, and you will add all the x squared, and the total is 330. And you put that in the formula now. Now the formula is the summation of x squared, which is the summation of x squared is 330 here. The J26. minus summation of x then square. So the summation of x is 40. So this symbol means square of 40 over 5. Why 5? Because our respondents here are 5 only. So over 5 all over 4. Why 4? Because our over is n minus 1. So you have to put this in the parentheses to perform whichever should be performed first mathematically. Now, let's try to again review the formula. This is now the variance formula. The summation of x squared. So you have to square first. Then the squared shall be divided by the number of respondents. The quotient will be subtracted from the sum of the x squared. And the result shall be divided by n minus 1. So that is how to compute manually using variance. Okay. So if you look at the manual computation is 2.5. which is closer to the shortcut. So this is now the shortcut. If you look at the shortcut using Excel, you just do the command equals, type var.s because you are using variance of the sample. But if you are using variance of the population, that is var.p. Then open parentheses, you highlight the data. Example here, from 10 to 9, you highlight, then enter. And the variance is 2.5. That is the shortcut using Excel. But if I ask you to do the manual, you have to get the square first of every x, and then you get the sum of the square and you put in the formula. And the formula is this, the summation of x squared here, the summation of x squared minus summation of x squared over n. And this is now your variance. So meaning you have to repeatedly do that in question number 2. So the same manner, you are going to square every x and then you get the sum you put in the formula. So you finish that in question number 2, question number 3, question number 4, and question number 5. So meaning there are, if you look at your manual computations, there are 5 variances for each question. That's the manual computation. But if you do the shortcut, because I introduced the shortcut, you can also var equals var.s, highlight the data, okay, and everything shall be computed, the same shortcuts here. As you notice, 0 is the variance for question number 4 because there is no response that deviates from the other responses. So all of them rated 10. So meaning no deviation, the variance, no data vary from the other responses. Okay, so that's why it's 0. Now, what is important here is to get also the total of the responses. So example, respondent number 1, the responses are 10, 8, 9, 10, and 8. You get the total, so you just add them. By shortcut, equals sum. Then highlight the data from 10 to Q5. Then you repeat that to all other respondents, so you have here the total. Now, since in the formula of the Cronbach, there must be variance of the total. So in other words, after getting the variance of Q1 until Q5, you also have to get the variance of the total. And the variance of the total is simply here. You are going to make equal var s of the total. If you do that manually, so the same. You consider 45, 35 as x here. These are the x, and then you square them. You get the sum, you put in the formula. Your variance is 45.3. So which is the same here. And in the formula of Cronbach, since in the upper part, you need the sum of the variances. And what you mean by sum of variances? Sum of the variance per question. If you look at here, you have variances here from Q1 to Q5. You get the sum, and the total is 16.4. So you simply do the command equals sum, open, highlight the data until Q5, enter. And that is 16.4. This is now the data for the upper part, the summation of VI. And the VT is the variance of the total. Wherein we have to variance of this total. Okay, you put that in the formula. If you look at now, so I can show to you that the formula should be put in the parentheses in order for mathematical operations to perform correctly. So 5 because there are only 5 questions, over 4 because it's n minus 1, times 1 minus the sum. A while ago, our sum is 16.4 over 45.3, which is the variance of the total. And you put that in the formula, the answer is 0.79. And 0.79 is acceptable because it belongs to the scale that is from greater than 0.7 and less than 0.8, and it's acceptable. So meaning you are